Well, hey guys, it's time for us to talk about some math again. Just sitting outside on this beautiful, beautiful day. Hope you've gotten to get outside and see some beauty in nature. And I want to talk about some 3D shapes. Like, here's my baseball. I found a baseball in my house. It's a 3D shape. It's got length, width, and height, and I can hold it in my hand. It's not a drawing on a paper. And here's my peanut butter container that is also something with length, width, and height. So we're gonna be talking about that. And I also have my big blue box that has length, width, and height. Now these three shapes are three-dimensional shapes. They are shapes you can hold in your hand, shapes that you can play with, you can build with. They are ones that you can do all kinds of cool stuff with, a different kind of art there. But today I want us to talk about how three-dimensional shapes have faces, vertices, or a vertex, and edges. Faces, like, ooh, I got my face, but it's a little different. A vertex and an edge. Now, I'm gonna start with my big blue one here. A face is the flat side, has to be flat, side of a 3D shape. So this shape right here has, this 3D shape has a face right here, right here, right here, right here, right here, one on the back, and one on the bottom. So if we just counted the faces, the flat sides, we'd have, let's go with the big ones first. We'd have 1, 2, so there's 2, and then we'd have 3, 4, if we count the ones on the bottom, 5, 6. It has 6 faces. Faces are those flat pieces on a three-dimensional shape. Now let's think for just a minute about my baseball. It's a sphere, and you might think, well, does it have any faces? Nope, because a face has to be flat. The sphere is curved all the way around. So this actually has 0 faces. You might say, well, Ms. McCurry, you could draw a face, like a smiley face on there. That's a different kind of face. A face for a three-dimensional shape has to be a flat side, That's very important. Now let's talk about our big box, or this is a rectangular prism, because this face is it's like a rectangle, kind of like a square actually, but squares are rectangles. This face is a rectangle, so it's still a rectangular prism. If you look all around, all the sides are gonna have that same face. So there is our rectangular prism. We're gonna talk about the other pieces of describing a three-dimensional shape with our big blue box here. Now, if we were talking about edges, an edge is where 2 faces touch or meet. So if we're looking at this, I have an edge right here because this face and this face, they come together and they meet right here. This is an edge. And then if I turn it around, I've got another edge right here because this face and this face meet right here. Now let's just look at a few more here if we can. If we look at this shape, we've got another face and another face right here meeting. So I've got an edge right here. Those are the edges to a three-dimensional shape. It's where those 2 faces meet, okay? So our rectangular prism, this big box, has faces and edges. But think about our baseball. Does it have any faces? No? So if it doesn't have any faces, it can't have any edges either. So this rectangular prism had 6 faces, but you know what, ladies and gentlemen? It has 12 edges. The ball, 0 faces, 0 edges. but that's what happens in a different kind of three-dimensional shape. Our last describing piece of the three-dimensional shapes is a interesting word, a fun word called a vertex. And a vertex, we have to think, okay, first of all, does my shape have faces? Remember those flat sides, the faces? Does it have edges where my two faces meet? My edges. But a vertex, ladies and gentlemen, is where not two faces meet, but three. I kind of like to think of my vertexes as corners. So if you look at my rectangular prism right here, I have a face, a face, a face. That's three. So right here, this little corner is a vertex. So there's one. And then if I look over here, look, there's another one because here's a face, here's a face, here's a face, there's two. So if there's 1, 2 right there, let's just see, let's just turn it around. I'll hold those right there. There's 2, oh, look at that. There's 3, 4. So here's 5, 6, 7, 8. This big rectangular prism has 8 vertices or vertex. For more than one vertex, the plural is vertices. It's a little interesting word. But when we're describing three-dimensional shapes, we want to think about, first of all, faces, okay, flat sides, edges where those two faces meet, the edge is there, and then the vertex where 3 faces meet. Gotta have at least 3. So let's think about our baseball. Does our baseball have any faces? No, a sphere has no faces. Does it have any vertexes and edges then? Sure doesn't. If it doesn't have any faces, then it doesn't have any edges, the sides can't meet, and then doesn't have any corners. So this is something that, of course, would roll on the floor and would not have any anything to slow it down. But then, I showed you earlier the peanut butter jar. Now, it has a curved side, so that's not a face. But what about like the ends here, the things that help it stay standing up top? That's a flat side, so that's a face, and that's a face. But does it have any edges? Do 2 faces meet? Well, is this one a face? No. So it just has 2 faces and no edges, no vertices. Oh well. Well, today as you're looking through and talking about your 3-dimensional shapes, you are going to think about them and how many faces, edges, vertices, vertexes that it has. And that can help you describe your 3D shapes.